Okay, this might be a long video, but I'm making this video just for sort of like an information and designs tips, stuff like that. Yeah, I need to have copper. The area that I'm selecting right now is copper, bottom copper. So but what I usually do to create the areas where the copper is going to be placed is using the silk screen. I'm using the S2. That will be the bottom silk screen for that purpose in green, so I can route the design throughout using the silk screen. So right now that's what I'm doing. The setting that I'm using is 45 degree. So every time I trace the line, it will also automatically create a 45 angle trace. Basically, it's going to follow that design. If I press the space bar, it's going to have a different settings of tracing, routing. That's okay, I can fix that later. Routing the area, the copper area zone of this design. So that's why I'm making the video as documentation of how to place or create a copper area on using Sprint Layout 6. So this is pretty simple. The only thing you gotta do is just try to trace the line, just follow the green line the one that I already traced or placed on the design, and continue until it's complete. So do not let go the mouse until it's complete. So there you go, so it's ready to go. So okay, I think I made a mistake here. I forgot to give a space for the standoff area. Okay, this one here, the standoff cannot be touching the copper because that might create problems. That's why I wrote it here. Standoff cannot be in contact with copper areas. So trying to give it some space. So the standoff, it can be made of metal, and one example, if you have a metal standoff, you're not going to be able to use it on to secure the PCB to the chassis. So that's why I gotta give some space. So the diameter of this sort of like a screw mounting point is, I think it's 8 millimeters. So for example, I'm gonna trace the line. Let me see, I got 9. That's okay. I got more. I think it's 10. It's fine. So I need to make sure that that I have plenty of space around the standoff hole or securing point, something like that. Don't worry about it. Okay, I think I gotta make it one more time. It's okay because I can do this really fast. It's not really difficult to do. Also, with the notes of Mr. Stewart, to keep the trace really thick to ensure the current is going to travel with no problem. But according to this line, depending on the length of the copper area, it can withstand about 61.5 amps. So what the idea that I have this morning is that I actually can place 2 layers of copper. The red one is the top layer of the PCB, and the violet, the violeta, it's not so violet, that's really difficult for me. Violet is the bottom copper layer of the PCB. So one example, if I place the bottom one under the red one, it will create a 2 ounces of copper. So that will reinforce the traveling of current is going to flow with better. It's not going to be less resistant. So basically 2 layers of copper equals 2 ounces, about 2 ounces of 70 micro something amp. I don't know, micro amp, something like that. All right, so that's why I'm making the video as a reference, so I can look at it. Maybe I have the idea. Also, I think I gotta move this fuse area, because I was thinking that if you are going to use the Faston connector here, the Faston connector, the fuse, it might be on the way. So to avoid any obstructions of the connectivity, I think I gotta place this fuse. It's not gonna change the circuit, it's going to be the same thing. So it's going to be a lot easier. So the only thing I gotta do is just move this fuse, place it here, and the terminal on this side, so it's not gonna be any obstruction of the fuse. It might be on the way. So that's the idea that I have just a few minutes ago. So a few minutes ago, yeah. So I was looking at the part number. So it's 15,000 microfarad times 3. So we're gonna have 45,000. Did I say that right? Microfarad. That's wow. That's a lot. Also, the orientation of the terminal screw, I think we need to change that. I really don't like the way it looks. I think we needed to place it in a way that I think, let me see if I can fit 3. I don't think it's necessary to fit 3. We only need two of those. So I don't think it's really needed. Also, this standoff, I need to isolate, separate the copper area from that standoff. So that's really important to avoid any short out, because even though it's ground, it might be a good idea, because it's going to turn into ground. It's going to turn into ground. It's going to be on the chassis. So that I think we can keep this one as it is. So for example, after we secure it with the standoff, it's going to be in touch with the chassis. So this is ground. I think it should be good. I think it's a good idea to leave it like as it is. I'm not sure. That we gotta think about it. And also, I was able to make this capacitor. This is actually the filtering, and we did the snowbird caps. I think they can be attached to the bridge rectifier. You can solder that before you put it on the PCB. So we need these capacitors, C3, C4, C5. So those are the snubber caps for the bridge rectifier. We had all these. Now the task that I had to do today is making the connections, identify every single component on the PCB to have a list of components. So I always keep saving the file just in case. So I'm gonna trace the line right now. I'm going to do that right now. So I'm gonna make a trace the zone. This is the copper area. So I'm gonna start to do that right now one more time, because I forgot to isolate this particular standoff. Depending on the situation, if we need to eliminate some standoff, we can do that too. So we can eliminate the standoff that are not really needed. But I think in some areas of the PCB is really needed to have standoff, because we're gonna have 6 large capacitors. I'm not sure they are pretty heavy. I'm not sure they are really heavy. I don't know how much they weigh. But the PCB also is another thing. The PCB is 1.6 millimeters in thickness. So I'm not sure if the best choice is to have a thicker one, a 2.0 millimeters thickness, or the copper clad PCB. Just the fiberglass area. I'm talking about the thickness of the fiberglass area, not the copper area. The copper area, we can use 1 ounce, and we can use soldable areas to reinforce the current that is going to travel throughout the copper area. So also making everything thick, wider, it will help improve or lower the resistance on the circuit. So we gotta keep as low as possible the resistance. So that's the idea right there. So there you go. We got that. So we got a lot of copper. We had so right now the center of the start ground, the ground, basically we have 2 layers, the top layer and the bottom layer, just to avoid any micro resistance. So we have 2 layers, so that will help improve the connectivity. So we have also 2 layers here. The red area represent the top copper area of the PCB, and the violeta, I should change the violeta to another color so I can pronounce it correctly. Let me see another color. The size is different. So let's go with how about green? I think green is better. Green. So now we know that the all green is the bottom part of the PCB, and the red one is basically the top layer of the PCB. So I'm going to change this to a name that I can pronounce. green button. There you go. So now we have it correctly identified. This one is just a silk screen. This is a S2 silk screen. I'm using it as a tool, and someone is making noise. It's okay, don't worry about it. So right now I'm going to continue here, making the adjustments and stuff like that. I'm making a new, I have to update this, so actually I need to move some stuff around here so I can have some room. I need to place another cap here, so to generate the part number, so it's going to be identified. So that's a good thing. I think I can delete this one. Okay, it's okay. It's just, so we have these capacitor, we need a bleeder resistors, so we need to change these numbers to 15,000. There you go. U micro, there you go. We're gonna change the other one. There you go. All right, we need to get another one. So I'm going to generate the identification from this simulation, so I can place those numbers into the PCB. So we're gonna create the schematic. From this schematic, we're going to identify all the components on this PCB power supply. I forgot to mention, sorry about that, it is for the class AB audio amplification. So this is the design. According we are following this one here. Basically this one is the actual original one. I think there's some elements that I gotta figure out here. I think I see 100 microfarad. I don't think we're not gonna have a space for those. This is another filtering thing. The guy is making a lot of noise. That's funny. All right, let's start with this one, C15. Let me save this one. C15 is on the bridge rectifier 1, BR1. So it's right here, BR1. So it's C15. It's basically this one here. So we're gonna create a component. So this one is C15, 0.1 microfarad, 0.1 microfarad. This one should be 250 volt AC. Just the AC. Sorry about that. There you go, AC. So we got a C15. Let's go. Yeah, that's fine right there. C15. And then we need to identify the other one. Also the orientation. Yeah, we need to eliminate this one here. The copper. I'm sorry about that. The standoff cannot be in touch with the copper area unless I can create a new copper area. Oh, I'm sorry, I made a mistake right here. It's okay, don't worry about it, guys. I always have tricks. One example, I'm gonna copy this one selection. I'm gonna copy it. So from what the hell I did here? So I should have it. I think I forgot to select. I gotta select this one here. Press the shift button on the keyboard so I can select both at the same time. Build the group, and then I'm gonna copy this one here. Let me see, it's right there. So from here I can create a area that is not gonna be in touch with this copper area. So basically what I gotta do is, the only bad thing is that it might be weakening. It's going to weaken the I don't think it's a big deal. I think I can make it work. I can make it work. One sample, I'm going to split the group, and then I'm going to create a S2 area to generate a measurement, sort of like a guide, so I can make it. There you go. So let me see, I can make it a little larger. Let me see. I can go with the, because we need a, depending on how thick is the standoff. The standoff, we gotta look for the standoff. I can keep making changes later on, so it's okay. So right now we have this idea. I'm going to remove this, and we have that. So I gotta create a area that is going to be empty, the empty area. So basically, let me look for the center of this. I don't see the center. Okay, I gotta turn this into. Should I do that? Let me see. Hold on. Okay, give me a second. I got the idea. Okay, so I need to copy it. Should be copied then. S2. Okay, it's not showing me the center. Let me see. Hold on. Okay, that's the copy right there. Let me see. I got an idea. How about red? Let me see. Set layer. If I choose, yeah, that might be difficult if I do that. Okay, that's the area that I need. That's the area that I need. So I can make it thicker. If I make it thicker, I gotta increase the thickness. Okay, I'm gonna increase the thickness. Okay, and then I gotta make it larger. Okay, I think I got it. Okay, I think I got it. Something like that. But I need this. That's the trick that I have. You will see. You will see. All right. So I need a copper area. I think I can make this thicker. Let me see. It's fine. I can make it thicker. I can make it work. It's fine. All right. So I need to create a new zone, but I need it to see where I'm gonna trace those lines. So what I'm gonna do, I'm just gonna create the zone area. S2. Let's go with S2. All right, cool. We got that. And then I'm gonna generate a new area, but with this reference. You'll see. Unless it's not necessary. I think I'm doing a lot of work here. Unless it's not necessary. Okay, let me see if I can enable that. I think I can make it work. I think so. Okay, so the only thing that I gotta do is go here. I got that area squared out, so I'm gonna see if I can do that. There you go. There you go. We got it. I know we got it. So I need to close this. There you go. All right. There you go. So that's the idea. And we need to hold on. Give me a second. We're gonna complete this connection here. So we're gonna have a open area. So the standoff is not gonna be in touch with the copper area, depending on what we are going to decide. So right now, if I remove that, we had that empty space right there, so we can place the standoff. So I'm gonna look for the standoff, and let me see. It won't let me take it. Come on, man. Oh yeah, I forgot that I split the group, and then I can select this standoff just to see how much space we need. So let me see. I think I gotta make it larger. Yes, I gotta make it larger. I think it's too. We need to avoid any contact with the copper area, because there is voltage involved there, so that's pretty dangerous situation right there. So let me see. Okay, almost close. I think I got it. Okay, cool. So now we're gonna edit this one here. I think this may be too advanced. I think this is too advanced, you know. Well, that's the idea. So we have that empty space. Oh, we need to know how big is the standoff. Also, that's another thing. We need to know the size of the standoff. That's another thing. Hey, hold on. Let me see. I need to have the. Oh yeah, this one is fine. It will have copper on the top and the bottom. So that's the idea that I have. For now, I'm gonna leave it there. So I'm gonna save this. So that's the idea. All right. Another thing that I gotta continue here, placing the components here. so we can generate a boom, a accurate boom part number. I'm just gonna use the numbers from this simulation. So we had the 100 nanofarad. Oh, we need the bleeder resistors also. I need to place the bleeder resistors. So they are. I was trying to find out where is the best place to put those bleeder resistors. So we need to have 2 of those. So I'm gonna eliminate this film risk capacitor for now. Later on we can figure out the best choice to place those components. So we got this already. We had the zone that is going to be isolated from the connections. But the bad thing about this is that it's going to weaken the connection. As you can see, we need to have more copper area here. That's the only bad thing about it. So I gotta figure out other stuff, other things. Or maybe I can move those standoffs to another area. So that later we can figure out that. So for now we are going to complete it, the schematics. So we're gonna start to identify those areas. I'm sorry, components. Sorry about that, components. So let's do that. This one, it should be C1. I don't think it's necessary to write down the capacitor. I don't think it's really needed. We only need the identification because you might choose a different value of capacitor. So for now, I'm just gonna type here 15,000, but it's not really needed. But it's not really needed to have it present on the capacitor. So all right, we got this one here. What is that? Okay, I forgot to C1. Okay, we got C1. What is the number? Oh, right here. It's okay. All right, C1. All right, put it right here. I think make it look nice. C1. I think I can make it bigger. That's too small. I'm gonna make it bigger. Let's go with 3. There you go. That's fine. Listen, we got 3. All right. I mean the font size. Sorry about that. So font size. Okay, we got now C13. We got C13. Let's do the identification. C13. C13. We got it. All right. So this is 15,000 microfarad. 1, 2, 3 microfarad. 100 volts. I forgot to write down 100 volts, but it's okay. We know that it's 100 volts. Okay, there you go. And then we're gonna place this number here, sort of like I think I look for a better place to. I think I can put in the middle. I think that down there is fine. I think it's fine. All right, save. I always keep saving because I spend probably a few hours every time I work with it's like 4 hours basically every day, something like that, maybe a little bit more, because I like to go back and rethink what I did and try to find the best choices. Just like the terminal, I was thinking, okay, the terminal, it should be placed here to the sides of the PCB, the outer line of the PCB, so it's not gonna be, the fuse is not gonna intervene with the connection of the terminal. So that makes sense right there. All right, let's continue here, and we have the C17. Let's make it a component. Okay, C17. All right, C17. There you go. So this one is 15,000 also. 100 volts. It's okay. I can make an identification later. It's okay. It's not a big deal. So the most important part is the identification of all components. So this bridge rectifier 2 is this one here. Okay, this is BR2. That's really important. So I'm going to identify this one here. Also the part number. I forgot the part number. I gotta look for the part number. So this is 50 amps. I think it's a 600 volts or 800 volts. I don't remember. I gotta look for the component and place it here. The part number. Or also here. on the comment is a 50 amps. 50 amps. I think it's a 600 volts AC. 600 volt AC. I gotta look for the part number. So this is BR2. BR2 bridge rectifier 2. So that we got that. So it's right here. So to have a good identification of each individual component, so we don't make mistakes on the layout. So I think I forgot. Oh yeah, BR1. Why is it so small, man? Make it big. This is too small though. BR1. I place it here on this corner. Let me see. BR2. What's the size of this one? Oh, 3. All right, let's go with 3. It's okay. All right, let's go with 3. All right, there you go. 3, and then we can move. Oh yeah, thickness. Bold. The font should be bold, so it's going to be a lot easier to see on the PCB. If you make the font way too small, you're not going to be able to see some component values, or I'm sorry, component identification. So we got the fuses that protect the bridge rectifier in case something goes wrong with the bridge rectifier. So we need to have a fuse just in case something happens, because they are semiconductors. Sometimes they go to short out for some reason, you know, the age of the component. So this is F3. For now it's 15 amps, but I think that with the 10 amps should be just fine. 10 amps. It's just an extra protection. So we got this one here. This is a component. This is a F3 fuse, F3 value. Let's go with 10 amps for now. And then we decided we got 10 amps coming. This is 6.3. Sorry about that. Let's go with the small one. 5 millimeters by, god damn it, I forgot that. 5 millimeters by 20 millimeters, or 6.3 millimeters by 32 millimeters. So that's why I select this fuse, because this one here you can use 2 types of fuses, so that will help the time you don't have the one side, you can have the other side. So 5 millimeter by 20, or 6.3 millimeter by 20, by 32 millimeters. So that we had 2 choices right there of fuses. Oh yeah, I forgot to enable the fuse. Okay, visibility. I think I can place it right there. It looks nice. Oh, hold on, it's okay. Forgot to move only that's fine right there. Terminal. I don't think we need to identify the terminal. I think that yes, it is important. Yes, it is important to identify the terminal, because this is the connection for the AC windings of the power transformer. So we need to also identify those two. All right, I can do that. It's okay. So I sound like I talking to myself. All right, we need that. I mean, we got that. Sorry about that. F4. Let's continue with F4. Let's make the identification component. There you go. Let's go with F4. So man, capital letter, bro. Hey, we got it. So this one is a 10 amps for now. I think 10 amps should be just fine. 10 amps. This is 5 millimeters by, oh Jesus Christ. Okay, 5 millimeters by 20 millimeters. There you go. Or 6.3 millimeters by 32 millimeters. All right, we got it. We got that figured out. I think we can place this identification down here. It's okay. Later on, I can fix some other things that I need to make sure the distance between the component. This is the trick that I do. This is really effective. It's not. I don't think it might be that precise, but it does work. It does work. I always try to make the outer line to be. Oh, this is not symmetrical. As you can see, it's not symmetrical. Something happened here. Something happened. It should be here. I gotta maybe I move it by mistake for some reason. Let me see. Hold on. I think I made a mistake here. Hold on. Let me see. For some reason, it's not okay. It's playing with my emotions right now. That's not good. I need to make sure that I have 200. You see what I mean? So I gotta do some adjust. Maybe I move it by mistake, because I needed to make sure that okay. I did something here. I probably move it by mistake. I need to make sure that I have snap to grid. Yeah, there you go. I see what happened. Let me see. So, I used snap to grid just to enable the component to be on the grid. You see, I made a mistake here. It's okay, don't worry about it. We can fix it. Snap to grid. You see, let me see. I gotta make sure that it's centered out. Yeah, it's centered out. We got it. We got it, bro. It's not really that difficult. Snap to grid. There you go. And then snap to grid. It's perfect right there. So we can fix it. All right, and then I gotta make sure that it's centered out with the perfect. Okay, hold on, I moved it by mistake. All right, it's okay. Save it, don't forget to save. Really important. Save it. Okay, let's wait. Oh, there you go. All right, let me see. Now I gotta see if everything is fine. I need to make sure that the trace is still not correct. For some reason, it's okay because I can keep adjusting the placing the traces, the component, and then I will do the tweaking adjustments to the PCB to make sure that everything will be sort of like symmetrical. Everything should be symmetrical. The best I can, I think. Let me see. Here, I think I gotta do the same adjustment. Snap to grid. Yep, I knew it. Let me see. Okay, now it's accurate. Let me see. The distance should be equal. We need to have 200 millimeters. Let me see if I can. Gotta fix some stuff here. Snap to grid. Okay, let me see. Yeah, it's correct. Okay, hold on. Let me see. Yeah. Okay. I see. It's fine. Snap to grid. There you go. And then I can keep adjusting the PCB. Snap to grid. Okay, perfect. Okay, snap to grid. Okay, let me see. Yeah, there you go. Cool. Let me see. Now I need to know if I have the accurate 200 millimeters. So that's why I create this line that does have a 200 millimeters in length. So I want to see if this line will match the design. If the line is not matching, that means I gotta do some adjustments here. So that's fine. I can keep making adjustments. It's okay. Let me see. Okay, I see. Oh, maybe because I copy the PCB to a new area, probably the grid got messed up for some reason. So it's okay. I can fix that. I'm gonna fix it. Snap to grid. There you go. Let me see. The distance is still 200 millimeters. So for some reason, let me see. This one is correct now. I just gotta snap to grid. So that means I gotta move some stuff around here. Snap to grid. Okay, there you go. So this, I make it thinner because I'm using this as a guide. Okay, this is the center. I make it thinner. Gotta just making sure that everything is symmetrical as possible. Snap to grid. Sorry about that. It's a layer, so I use this as a guide. Build the groove. So this, I know this is the center, so it's 200. Okay, split the groove. Split the groove. Just want to make sure one more time. Okay, this one 200 millimeters. All right, we had 200 millimeters, so I needed to move it here so I can use it as a guide to keep making sure that I have everything squared out. So like I can move this line here to see. You can see we still need to have some adjustments. As you can see right here. Okay, this one is fine. This one is fine right here. This is fine. Let me see. Okay, this one is fine. I can see that. Yes, this one is fine. Okay, good to go. All right, I just try to make sure that. Sorry if the video might be a little boring, guys, but this is sort of like the way I do the PCBs, and try to make everything symmetrical as possible, so the best I can. To explain you better, you're probably wondering why I'm doing this. As you can see, after I select one sample, I select the one line, one sample, I select, sorry about I'm talking way crazy stuff. After I select one line, the line, it will give you the center of that particular line. One sample, if I measure, one sample, I'm gonna create one line besides the other one, and then place it at the end of the other one. One sample here. Let's make it simple, same thickness, 20. There you go. If I copy the line from the center, this is the center of the line. So basically, I can use it as a guide, and that really helps. It's sort of like a geometry, something like that. I don't know. Something like that, something similar to that. And then I'm gonna move this line all the way up. It's going to be a 100 millimeters line. Show you that this, in fact, is less than that. What? What happened here? What? I did not make the correct line. What the hell's going on? Oh, I see. I'm a dumbass. It's okay, guys. I made a mistake. I was doing the sample with the arrow line. It's okay. At least I know that that I see that I made a mistake. It's okay. We always make mistakes. Don't worry about it. Okay, let's continue here. Snap to grid. This one is 200 millimeters. I think this one is wrong, so this one is snap to grid. There you go. We got it. We got it, guys. We got it. There you go. So this one, let's make it thinner too. So this is just a guy. Okay, we had 200 millimeters. Good to go. I need to keep explain you guys the reason why I use lines as a sort of like a tool, so you can make sure that everything will align correctly on the PCB, just to make it also symmetrical the best you can. So I need to look for the center of this line. So let me see, what is the center? Okay, let me see the center of this line. What is it? It should be there you go. That's the center. Sorry, but okay, there you go. Right here, this is the center. So basically, splitting the line. Okay, so if I move this line all the way down to the middle of this blue circle, there's a blue circle right here, it will tell me that I got 100 millimeters. So that's the half of the line. That's a really good tool. I mean, those guys from Spring Layout, Abacon, they know what they're doing. So you see, you can use it as a tool to create symmetrical PCBs right now. So I know if I move this line, one example, this line to the outer lines of this design, it should tell me where is exactly the half of this PCB, and then I'm gonna look for the center, and you can see there is a half of the PCB, and then I can use this tool line as a guide, so I can arrange the components in a more precise manner. You can see the center of this capacitor. It should be accurate, pretty accurate. Let me see. Let me try it out. I think if I move the line, I think it's a few millimeters that were off. It's off a little bit, so I gotta fix that. To make sure that everything will be aligned correctly on the PCB. That's the way I do it. That's why I spend a few hours doing the design. So I will continue here. I'm gonna stop the video, and then I will continue making the proper identification using this schematic from the simulation, so just to be sure that everything is correct. That's it, guys. I'm gonna cut the video. I hope you like this video, and I'll probably make another video about this this power supply design and tricks that I have to create the PCB. All right, have a good day, guys. Let me wait for the there you go. All right, good guys, have a good day.